So we did do our capture question. You guys would have discussed that. The reason capture questions are important, you guys, because it helps you know if you are understanding the material. It is your test every day without being graded. So if you could answer these questions without using your notes, that's awesome sauce. If you need your notes, but you're still able to do that, that shows you might need a little review. If you have no idea what I'm talking about, that is a red flag, and that means you need to get some help or you need to do a lot more studying of the material each day, okay? So that's why I do those capture questions. It's a temperature taker. It sees where you're at. So make sure that you take them seriously, especially being an online class. You have to advocate for yourself. I'm not able to see you right now to know if you're confused or if you need help because of the Zoom. So make sure that you're taking those seriously. Also, we do have a quiz next week, and we'll be talking about that later in the week. We are meeting this Friday for fourth period, so keep that in mind as well. We will meet this Friday. I know I gave you last Friday off, but we will meet this Friday. Maybe not that long, but just for a little bit. Okay, so I have, let's see, how many kids do I have in here? Boop, boop. All right, we're gonna start off now with our lovely element versus compound. Off to the right, you should see a spot to put your responses. I have 32 in here, which is good. I think I only need 2 more of you to log in. Joinpd.com, KTJLVV, KTJLVV. Now, the reason why I like to have you guys put your responses in, I can actually see them, which allows me to kind of figure out if there are any misconceptions and kind of discuss those with you guys. I can actually see you typing them in real time, which is kind of cool. We got some good stuff popping up here. Awesome. Excellent, excellent, excellent. Really, really good, you guys. Okay, so I am going to flip the switch here. Most of you guys got responses. Now, what I have in front of you are actually definitions. So I'm going to break this down and show you how you can actually take the definitions and then talk about the differences, because there is, ooh, what did I just do? I don't want to pause my screen. Uh-oh. What just happened? Okay, give me 1 second. I think I need to stop share for a second. And pop in again. It said I paused my screen, which I don't know what that means, but I don't think it's good. All right, so if I get my annotations going here, come on now. There we go. So elements can be broken down, cannot be broken down, and compounds can. So one difference might be that these can be broken down, compounds can't, all right? So I would make that statement, elements cannot be broken down. Oh, I said that backwards. Terrible, Hughes, terrible. Elements cannot be broken down, are different than compounds can be broken down, okay? So that's one difference. Compounds are chemically bonded, elements are not. That would be a difference. Compounds can be separated, elements can't. That would be a difference. You see how you can kind of take the definition and then work through those differences. A lot of you guys said elements are made of one atom only, one type of atom only, and elements can have two or more. So those are excellent. One thing I did not see is that one thing that you can add to your capture questions, elements are found on the periodic table, compounds are not. You can look up an element on the periodic table and find it. Also, the codes we use a symbol or one capital letter for an element, where compounds, we use a formula and it's more than one capital letter. So that is another way you could discuss a difference between those. So I know that's kind of sloppy, but I wanted to take the definitions from our notes last week and show you how you can then write a difference. Because when somebody asks you the difference of something, just writing two definitions down doesn't really answer the question. Do you guys have any questions about elements and compounds before I move on? Throw it in the chat if you need to. All right, wait time. What do you got for compound versus mixture? This has been an interesting one today. This has been an interesting one. Compound versus mixture. Look good, you guys. Well done. Now, if I don't clarify something as I talk about these two, please say something and put it in the chat if it's hard to say it out loud, all right? So for our compound versus mixture, you'll see the definitions actually at the top in the blue. That's from our notes. I just copied and pasted that. And below, I kind of have some things that you could say are different. Compounds are pure, mixtures are not pure. Compounds are chemically bonded, mixtures are not chemically bonded. And I hate using the same word when we have something like mixture to say, hey, they're mixed together, but probably maybe another word you could say is they're blended together, not physically bonded. Compounds have a fixed ratio. Now, what that means is, for example, with water, we're always going to have 2 hydrogens to every 1 oxygen. And it will always, always, always be like that. If it is not a 2-to-1 ratio, it's not water. And it's got to be chemically bonded. Where a mixture does not have a fixed ratio. So think about salsa. Every bite of salsa I take is going to definitely be different, and it doesn't matter how many green peppers or tomatoes or anything are in each bite. Like, it's not fixed. Or even like a homogeneous mixture, you could actually have it where it's not fixed as well. You don't need a certain amount in there. Yeah, yummy. I know, now I'm making you guys hungry. Lunchtime. You don't need a certain amount in there. It's not a fixed ratio. The other thing I didn't write here is the code. We use a formula for compounds, and with a mixture, it's going to be something and. Remember, we use that ampersand. Oh, that looks really bad. Let me try to erase that. Will it let me erase it? Nope. Let me try again. Here and here. That plus sign. So when you have a mixture, it's going to be something and.
Can you go back to the slide 1?
Kaden, at the very end, we'll have time for that, and I'll go back.
All right.
Thank you. Are there any other questions on compounds and mixtures? All right, I'm going to clear that. And then our last one for vocabulary today, heterogeneous mixture and homogeneous mixture. Let's see what you have for your thoughts on that. Heterogeneous and homogeneous mixture. I agree, Asher. Right there with you. These are pretty good, you guys. I'm going to do some clarification on a few of them, though. For those of you that are thinking heterozygous and homozygous, we're not talking genes. This is this isn't biology, it's chemistry, but same idea for the front part of the name. We have the definitions here. Okay, so again, I'm going to kind of break down what I would pull out to be the same or different, or to write out those differences. So if we have evenly mixed, this would be evenly mixed, but this is not evenly mixed, okay? So that would be a difference. With heterogeneous, you can see the separate parts, but with a homogeneous mixture, you cannot see the separate parts. So like when it's dissolved in Kool-Aid, I can't physically see the sugar and stuff in there if you make it correctly. If you don't, if you're a sugaraholic and you have it sitting on the bottom, that's just because you didn't make it right. But you should not be able to see the separate parts. Heterogeneous can sometimes separate, but a homogeneous mixture cannot separate, or I should say will not. If I were to break up every single piece of a homogeneous mixture, they would all look the same, where a heterogeneous would not. So some things we call homogeneous, these are solutions, these are not. Alloys are a mixture of element metals, and they are actually evenly mixed and stuff. So an alloy is homogeneous. It's not heterogeneous. And then one of the examples that I gave you guys, yes, like bronze, whoever just said that, bronze is another alloy for sure. And then we have colloids, which are kind of tough. Milk was the example and Jell-O was the example that I gave you in the notes. And these might not seem like you can see the separate parts, or that they separate, or that they're not evenly mixed. When I drink milk, it seems the same every time. But if I leave the milk in there for a month, oh no. I don't know if you guys have seen the Super Bowl commercial with the chunky milk and they're drinking chunky milk. I about wanted to gag. It was so gross. If it goes bad, it separates. You're right, Addie. So because that happens, that means milk is definitely heterogeneous. And if you've ever heated milk, you can separate the fat to the top as well when you heat it. Jell-O is tricky, but if you shine a light on Jell-O, you can actually see the little specks in it. So colloids really mean you have parts that are too big to get evenly spread throughout. So even Jell-O falls in that category, even though when we eat Jell-O, we don't feel like we're eating different stuff, like with salsa. Salsa is like right out there. Are there any questions about homogeneous and heterogeneous? If not, we are going to then.
I have a question.
Yeah.
So, not all milk has fat. Like, what if you have fat-free milk? Then, if you put it in the microwave, there would be no fat.
Right. You know what? It probably depends on, you know what I mean? I don't know if like almond milk, for example, or fat-free milk, like skim milk, I think it still separates. Because what actually creates that stuff to be what seems like evenly throughout is the homogenization process. So even if you have like skim milk in your, it still will separate. So I think most milks are like that.
Oh.
And someone asked about bread. Bread's not a colloid, but it's definitely a heterogeneous mixture. You can definitely see the different parts, the crust and the parts throughout it. So thank you, whoever asked about the milk. But yeah, I think even like fat-free milk still will separate out. And I guess I don't know all the millions of different milks. There's not millions, but for the most part, I would say it's a colloid. Great questions, you guys. Yeah. All right. On your piece of paper, you are going to write 1 through 10 on your capture questions. And I would write these out as you go. I'm actually going to put this on self-paced and let you do the 10 on your own for the next 5 minutes. And then we will spend time going over it. Calcium, salad dressing, sodium hydroxide is the NaOH, brass, potassium chlorate, steak, the fluorine there, salt water, air, and trail mix. I am all right, I'm going to stop and put you back on pace with me. So hopefully you should see calcium in front of you. I'm going to show the responses you guys said. We have, whoa, lots of elements, just a couple of compounds and heterogeneous mixture there. Now, one of the clues for calcium is that it is one word, okay? And because it's one word, it could possibly be an element. Elements are always only one word. So if you want to write that down as a tip for yourself when you're doing classifying, that can help. The other thing is Hughes is not evil. She's going to give you hints. This is your hint. I gave you a symbol with one capital letter. And if we went to the periodic table, we would be able to find calcium. We would be able to find calcium. So if I clear my drawings here and stop that, I do have a periodic table on here. And I'll show you with my cursor. Here's where calcium is. So you can look up and double check to see if your element is on the periodic table. All right. So calcium is an element. Number 2, salad dressing. I know right away that salad dressing is not an element because it has 2 words. Elements never have 2 words. And if you're talking about pretty much any food, almost all food, you guys, are mixtures. Very, very little food are pure substances. Now, the question is this heterogeneous or homogeneous? If you look here, you can see individual parts. So this, my friends, is a heterogeneous mixture. And I'm not going to spell that all the way out because I am lazy. But this is a heterogeneous mixture because I can see the individual parts and it is a mix of stuff. For part 3, let's see what you guys responded with. Whoa, awesome. Most of you guys said compound, and that is exactly right. Again, I gave you a hint. I used a formula. And that formula has more than one capital letter. You guys hear that tapping in the background? It's because my stylus is being ornery. It's not operating for me. I got an N, I got an O, I got an H. And if you look on here, you get your fancy name. This is actually sodium hydroxide, which I did not expect you guys to know. You'll learn that though, eventually. So sodium hydroxide has a formula. If it has a formula, you know that it is pure and that it is a compound. CPD is my abbreviation for compound. Number 3.
Or if you watch The Flash, you would know this stands for Central Police Department. Central City, because none
Hey,
of the Flash.
Kaden, will you mute yourself, bud? And then we have brass. Let's see. Brass is a tough one. Oh, dear. We got element, compound, heterogeneous mixture, homogeneous mixture. We got a little bit of everything. So it's one word, which can be deceiving, okay? Because then you might think it's an element, but it's actually not an element. We know it's not an element because if we go on the periodic table, we will find that it is not there, okay? So we have the option of compound or mixture. It's only one word, definitely not a compound. Compound is like 2 words, football, football, and you can take them back apart, okay? So if we have 2 words, it's a compound. This is not. This is a mixture. And the type of mixture it is it has to be homogeneous. And here's why. If I take the brass and I break it up into 100 pieces, all those pieces will be exactly the same. They will not look different, which makes this an alloy. Like bronze, somebody had said earlier, alloys are a mixture of elements. So brass is a tough one. It's a homogeneous mixture. Clear all drawings. Awesome. KClO3, let's see what you got. Woohoo! Most of you said compound, and that's right. I want to point out here, we have a lovely capital letters. We have K for potassium, C for chlorine, O for oxygen. K, C, L, and O. This is a formula which shows you it's a compound. Kiddos, that is a lowercase l. You'll either have a capital L or a lowercase l. This is not an I. A capital I looks like this. A lowercase I looks like that. So a lot of people forget about old school block lettering, and that's what we use for our formulas. So this is definitely a compound, potassium chlorate. Good job for those of you that said that. Oh, I've been talking about salsa, now I throw steak in your face. Steak is one word, but you cannot find it on the periodic table. So that tells you it's a mixture. And notice the different coloring right away. You see it is not the same throughout, okay? So that is definitely a heterogeneous mixture, which most of you said. Good job. Heterogeneous mixture. And then we have lovely F2. Oh, this one's tricky. Kind of tricky. Notice we have mostly element and some compound, and you might be thinking, wait, Hughes, there's 2 of them. That means they're bonded. Well, it does mean that, but remember we have something called a diatomic element, and this was in the notes. So this is how I know if maybe you took your notes or not. Our diatomic elements, there's 7 of them. You should have hopefully gotten your periodic table when you did textbook pickup. And on the back of that periodic table that we gave you, there are 7 diatomic elements. You don't need to memorize them. You have that table. You could use the table. Fluorine will never exist in nature just as F. It won't exist by itself. It is too reactive. It has to bond with another fluorine to be stable. So you only see it as F2 in nature, which is why we still call it an element, even though it has a chemical bond. So it is one of the 7 exceptions. So for those of you that saw that and figured that out, fantastic, good job. Hey, and just FYI, you guys, I am recording this lesson. So if I went too fast, you guys will be able to come back and look at it again. Salt water, we have 2 things. So that tells you it has to at least be not an element. It can't be an element for sure. Okay. Oh, somebody's in the chat. Just a second. My cursor is not helping me here much. So the fluorine F2, Maddie, yes, is an element. We would classify it as an element. Thank you for the clarification question. Now we have salt water, and salt water is 2 things. So if it's 2 things, or 2 words, I should say, it's going to be a compound or it's going to be a mixture. It cannot be an element. But water is a compound in and of itself, H2O, and salt is actually a compound as well. So you know you're not taking element, there's no element salt and no element water and putting them together. So this is not a compound, this is a mixture. And kiddos, when we have anything like salt or sugar and it dissolves, it will be the same throughout. So this is a homogeneous mixture. Homogeneous mixture. All right. My cursor doesn't want to work. Fluorine and fluoride, Suhan, are the same thing. It's just how we name them. And we'll get into that later this year. They're the same thing. All right, couple more here, you guys, and then we'll be done with all of this. 2 more. Air is tough. In the chat right now, type what is in air. Type what is in air. What are the things that are in air? Because as you look from your responses, we have a lot of different ideas. Element, compound, heterogeneous mixture, homogeneous mixture. In the chat, what is in air? All the things. All the things. We have, I'm writing them down. We've got N2, O2, CO2, chat's blowing up, excellent. Helium, hydrogen, methane.
I don't know what to do.
Kaden, will you put it on mute a second? Kaden, put it on mute a second, please. All right, obviously we don't have just one element and one compound. We have a mixture. All right. And that mixture is the same throughout. And here's how we know. We know because we can walk anywhere and breathe. We don't go anywhere and there's not oxygen. Even if it's thinner, it's still there. If you're on a mountain, it's homogeneous. So those of you that picked that, good job. And one last one before the bell rings. Trail mix is heterogeneous. How do we know that? Well, you can see the different parts. You can actually see them. All these different little parts. That is a heterogeneous mixture. Hey chemists, I just want to let you know where you find your homework. It'll be under Monday 9/21 if you are in classes 2nd, 3rd, or 4th, or it will be under Tuesday 9/22 right here if you are in classes 6th and 7th. But for those of you today, you click here and then that will pop up the homework. It says click title below. For classifications of homework. So that's right here. You're going to click that. And this is your copy. Do not make another copy of this. So that will pop up. And when that pops up, you're able to make changes to this. And you'll read these directions here on the first slide. And 4, 5, 6 there. Answer 7 and 8. And then number 8 says you need to make sure it's submitted. So where your submit button will be off to the right. So you will close these slides and then you will click submit. So I'm going to close these slides. And when I do that, I don't have a submit button over here, but you guys will. And you need to push submit. And then you will be ready to turn in, and then that will turn in your assignment to me. All right, chemists, make sure that you get that done by 4 tomorrow. Thank you.